A very important principle during the formation of solutions is that polar solvents dissolve polar solutes and non-polar solvents dissolve non-polar solutes. Okay, so this principle is known as like dissolves like. Okay, polar solute dissolves in polar solvent, non-polar solute dissolves non-polar solvent. Very important. Okay, if it is a non-polar solute, it will not dissolve in a polar solvent. So we know about polarity in bonds. For example, if we look at a bond like this, OH, right? We know that it's a polar bond because oxygen is highly electronegative compared to hydrogen. If we see a bond that looks like this, we know that it's a non-polar bond, or we know that it's a pure covalent bond or non-polar bond. There is no polarity in this. In this, there is a polarity because oxygen is highly electronegative, so it will pull these or it will attract these electrons towards itself, and hydrogen will get a delta positive. So this is a polar bond, and this one is a non-polar bond. There is no polarity in this. No separation of positive and negative charges in this bond, so this is a non-polar bond. For bonds, it's easy to know if a molecule is polar or not. What is a polar molecule? So for practical purposes, if you had an electric field in a, so let's say if you had a beaker with polar molecule, so I'm going to represent a molecule like this with positive and negative charge, right? And if there is a positive charge and a positive electrode and a negative electrode, or if there is a field in the beaker, then the polar molecule are going to be like this: positive towards negative and negative towards positive. So they are going to orient themselves like this. They are going to orient like this. So there is a positive center in the molecule and there is a negative center in the molecule. But if a molecule structure is given to you, how do you know that a certain molecule is polar or not? If it's a small simple molecule like carbon dioxide, for example, right? We know this is a polar bond because carbon oxygen has different electronegativity. So this is polar and this is also polar. But remember, this attraction of electrons and this attraction of electrons is same. So even though there are polar bonds present in the molecule, the overall molecule is a non-polar molecule. It's a symmetrical non-polar molecule. But if it's a molecule that is like this, oxygen, hydrogen, hydrogen, water molecule. If the molecule is like this, the attraction is this way, and the resultant of these two vectors would be somewhere in between, like this, right? So this is not a symmetrical molecule. There is a polarity in the molecule. There is a negative side and a positive side in the molecule. So for knowing if the molecule is polar or not polar, it's great if you know vector forces, but if you don't know vector forces, remember it as a general rule. And what is this general rule? The general rule is, if the polar bonds, so if you have a molecule like this, if your general molecule is like this, AXMEN, okay? If your general molecule is like this, and if the polar bonds, if the AX polar bonds are arranged, if AX polar bonds are arranged symmetrically around the central atom. Symmetrical around central atom. Then the molecule is non-polar. An example would be carbon tetrachloride. Okay, this is a molecule of the type AX4E0, right? There are no lone pairs around the central atom and there are 4 terminal atoms. And if you think about it, CCl bond is a polar bond. Now, the polar bonds, the CCl bonds, are symmetrically arranged around the carbon atom. So, this is a non-polar bond. Whereas, in a system like this one, ammonia, the NH bond, so this is of the type AX3E1, right? And the NH bonds, they are polar, but they are not symmetrically around the N atom. If you notice, they are on the 3 sides of the N atom and the other side has the lone pair, right? So this is polar molecule. Okay, now the solute is polar. It will dissolve in a polar solvent. And this we called as the principle like dissolves like. Like dissolves like. And the main reason or the main criteria behind like dissolves like is that the attractive forces in solute molecules are similar or comparable to the attractive forces in the solute molecules. So, solute and solvent molecules have similar or comparable attractive forces. That is why one dissolves in the other.